Let's have a look now at multiplying and dividing fractions. And the rules are a little bit different to adding and subtracting fractions. So if you remember with adding and subtracting fractions, the denominators have to be common, they have to be the same. It's not the case with multiplying and dividing fractions. Let's have a look at some of the rules. To multiply fractions, we multiply the numerators and the denominators separately. So as an example, 3 on 5 times 1 on 2, okay? We multiply the numerators first. 3 times 1 is 3. Then we multiply the denominators. 5 times 2 is 10. And the answer is 3 on 10. We try and simplify it where we can, and obviously we can't in this case. Let's have a look at the second rule. To divide by a fraction, we change the division into a multiplication and we invert the second fraction. So inverting a fraction just means turning it upside down. Okay. Another word that we use for that is the word reciprocal. I might just write that in here. Okay. So the word reciprocal, or to take the reciprocal of, also means to turn a fraction upside down. So 3 on 5 as an example, we're going to use the same fractions as before. 3 on 5 divided by 1 on 2, okay, by half. We're going to keep the first fraction the same. We're going to change the division into a multiplication, and then we're going to flip the second fraction. So instead of 1 on 2, it's going to be 2 over 1. And then we multiply normally. So 3 times 2 is 6. 5 times 1 is 5. And so the answer is 6 on 5. That's an improper fraction. Okay, so that's 1 1/5. To multiply or divide mixed numerals, we convert them into improper fractions first. So just as an example, if you had a mixed numeral, for example, 2 and 1/3, hopefully we know how to convert this into an improper fraction. You take the denominator, multiply it by the whole number, then you add the numerator. So 3 times 2 is 6. 6 plus 1 is 7. So 2 1/3 is the same as 7 over 3. And the last one, obviously just as important as all the others, we try and simplify all our answers where possible. Okay, while for example, let's say an answer, you might get 3 on 6. For example, if you're multiplying two fractions, technically, look, it's a correct answer, but it's not the most simple answer, or the answer in simplified form. You know that the better answer to write is in fact 1 on 2. So we always try to write our answers in the most simplest form. Let's have a look at some examples. Okay. So first one, 4 over 7 times multiplied by 3 on 5. Okay, so just as the rule says, you just multiply across. Okay, so 4 times 3 is 12. So before I do that, I might just write the working out first so you can see what I'm doing. So what I've done is that the 4 times 3, I've combined them together into a single numerator. 7 times 5, I've also combined those into a single numerator. So it's quite interesting with multiplication. Two fractions can be combined together to form a single fraction. Okay, it's kind of a very neat property of multiplication involving fractions. So 12 over 35 is the equivalent fraction to 4 on 7 times 3 on 5, or the evaluated expression evaluates to 12 on 35. Let's have a look at part B. Okay, 3 on 4 times 8 on 9. All right, again, same as before, multiply across. So 3 times 8 is 24. 4 times 9 is 36. Okay, this time round, can you simplify this fraction? 12 on 35 couldn't be simplified. That's why we left the answer the way it is. There's nothing you can divide the 12 and the 35 by to produce smaller numbers. But 24 on 36, they're both even numbers. So we could, in fact, divide those by 2. Okay, so I'm just going to use a different color pen here to show what I'm going to do in the working out. So if they're even numbers, so we can divide them by 2. 24 divided by 2 is 12. 36 divided by 2 is 18. They're even numbers again. We can divide those by 2 yet again. Okay, so you can do this a few times if necessary. Okay, so if you find simplification difficult, just try and divide them by small numbers and do it more often, and you're more likely then to get the correct answer rather than trying to remember the larger factors. Of course, if you know your multiplication tables, it does make it a lot easier. 12 divided by 2 is 6. 18 divided by 2 is 9. Can we simplify that further? Yes, we can. We can divide top and bottom by 3. Okay. 6 divided by 3 is 2, and 9 divided by 3 is 3. So the correct answer, or the simplified answer, is 2/3. All right, part C. 2 on 5 divided by 3 on 8. we're going to turn the division into a multiplication. Okay, so the first fraction, we'll leave it alone, don't do anything with that. We change the division into a multiplication, and we invert the second fraction. So that's going to be 8 over 3. So let's multiply across. 2 times 8 is 16. Okay, 5 times 3 is 15. Now that's an improper fraction. We can either leave it like that, but if the question asks you to convert that into a mixed numeral, this one's fairly straightforward. 15 goes into 16 once, leaving a remainder of 1, and we write the remainder as a fraction 1 over 15. Okay, let's have a look at part D. 1 on 3 times 5. When you have a fraction multiplying a whole number, we change the whole number into a fraction. And this is just the fraction 5 over 1. Okay, so 5 over 1, it really just means 5 divided by 1, and that just gives you 5. So we can safely change the 5 into a fraction without changing its value or what it represents. Now we multiply across as per usual. 1 times 5 is 5, 3 times 1 is 3. Okay, this is an improper fraction again. 3 into 5 goes once, remainder 2, and we write the 2 as a fraction 2 on 3. All right, let's have a look at some more examples. Okay, if you like, you can pause the video at this point and you want to give this a go, you're more than welcome to. Unpause the video and then check the work solution. Alright, let's have a look at part D now. Part D, we have mixed numerals this time, okay? What does the rule book say? It's going to be a lot easier to multiply these together if they were improper fractions. Okay, so let's do that. 2 1/3, okay, I think we've seen this one before. 3 times 2 is 6, 6 plus 1 is 7, so that's just the fraction 7 over 3, okay, times 3 1/2, so 2 times 3 is 6, 6 plus 1 is 7, okay, this is going to be 7 over 2, okay, now we multiply across. 7 times 7 is 49, 3 times 2 is 6. This is an improper fraction yet again, so let's convert this into a mixed numeral. Okay, 6 into 49, if you know your times table, should go 8 times. Why is that? 6 times 8 is 48. Okay, so that goes 8 times, remainder 1. And it's going to be 1 over 6. To check to make sure you got this right, use multiplication. 8 times 6 is 48. 48 plus 1 is 49. So that's correct. Let's look at part E. 2 on 3, all squared. Okay, if you want to expand that to see what happens, that's just 2 over 3 multiplied by 2 over 3. Okay, so that's what the squared means. It just means whatever's in the bracket, we're going to multiply it to itself twice. Okay, so itself and then another 2 on 3. Okay, again, multiplying across, 2 times 2 is 4, 3 times 3 is 9. Can't simplify that any further, just leave it. What about part F? Now, part F involves what appears to be algebra and two very interesting fractions. In fact, they look the same, just one's an inverted version of the other. So A over B times B over A. Now, we have to be careful here. A and B, A can't equal 0 and B can't equal 0. We haven't looked at division by 0 in any great detail, but let's just assume that they're not zeros. Okay, or some funny things will happen. Let's multiply across and see what happens. Okay, we got A times B over B times A. Okay, and if you know your algebra, A times B is just AB. B times A is just BA, but it can also be written as AB. And when you have a fraction where the numerator and the denominator are equal, okay, we just get 1. Okay, so this is a very neat property. So if you have a fraction and you multiply it by its reciprocal, so this B on A is exactly the same as the first fraction, just an inverted version, you're going to get 1. So as an example, if you had, for example, 7 on 5 times 5 on 7, okay, if the two fractions are identical to each other in every way but the denominator and the numerator are flipped around, the answer is always going to be 1. Right. What about part G? 3 divided by 1 on 4. Okay, we could turn the division into a multiplication and invert the second fraction, but we probably should convert the 3 into a fraction as well, just to make it a little bit easier for us. All right. So the 3 is just the fraction 3 over 1. We're going to turn the division into a multiplication, and then we're going to invert the second fraction, which is 4 over 1. Okay, multiply across. 3 times 4 is 12. 1 times 1 is 1. 12 over 1, nice number there, 12. All right. What about part H? 1/4 divided by 6. So notice it's the same two numbers, but I've just switched them around. So 1/4 divided by 6, let's do the same thing. Okay, that's 1/4 divided by 6 over 1. Okay. We're going to change the division into a multiplication, and we're going to invert the second fraction. So that's going to be 1/6 instead of 6 over 1. Okay. All right. Now let's multiply across. So 1 times 1 is 1. 4 times 6 is 24. Okay. Right. Let's have a look at part I. Part I, it's an equation of sorts. 2/3 times question mark equals 4/7. So we need to find what the question mark is. Okay. So the way we're going to do that is we're going to use some division. All right. So if we start off with 4/7, okay, and we divide it by 2/3, that gives us our question mark. Okay. So when you have a product, so two things being multiplied together to give us an answer, if you take your answer and divide by one of the numbers in the product, you'll get the other term of the product. All right, now we're going to divide these fractions together like we normally do. Okay, so that's 4/7, okay, multiplied by 3/2. Okay, we're going to multiply across. 4 times 3 is 12. 7 times 2 is 14. We can simplify that. 12/14, if you divide top and bottom by 2, okay, what do we get? We get 6/7. Okay, so if you have the fraction 6/7 and you multiply it by 2/3, you get 4/7. Okay, now there's actually one more example that I want to show you. All right, and I might just write it on this board here, so I'll just get it ready. And I want to pose this one, I guess, a bit of a challenge question for you. Try this one. Okay, so just move that out of the way there. Okay, have a go of this. 1/2 divided by 1/3 divided by 1/4. See if you can work this one out. Okay, what do we do? Okay, of course you can use your calculator to work that out, but being all division and according to BIDMAS, all right, order of operations, we just go from left to right. So 1/2 divided by 1/3, let's deal with that first. What we're going to do is we're going to leave the 1/2 alone. We're going to change the division into a multiplication, and we're going to invert the second fraction. And the third fraction is just left alone. Okay, now what we're going to do, we're going to do the same thing again. We're going to change this division into a multiplication and invert the third fraction. Okay, times 3/1 multiplied by 4/1. Now we're going to multiply across. 1 times 3 times 4 is 12. 2 times 1 times 1 is 2. The answer is 6. All right, now if you don't believe me, okay, let's try it. 1/2 divided by 1/3, okay, divided by 1/4, and we get 6.